Good morning everyone. Welcome to today's GATE video. Myself Saritha, Assistant Professor from the Department of Artificial Intelligence and Data Science at S.A.E.C Engineering College. Today let us discuss a topic about cross-validation in machine learning. Let's quickly look into the agenda for the day. So what is machine learning and what are all the types of machine learning and cross-validation, and we have different types in cross-validation, and finally we'll look into some of the GATE question for discussion. So the first one is, what is machine learning? We know machine learning is a branch of artificial intelligence where it takes the data from the past experience and it predicts the data and gives out with a decision. So this we call it as a machine learning. So the best example for this is when you go for a Netflix, when you use a Netflix, you will be watching some of the movies. So when you continuously watching the movies, it automatically recommends you based on your past experience. That is, it learns from your past viewing data and make better prediction what you might like next. So the machine learns from the past experience and it comes out with the predicted output. So we have different types in machine learning. First one is supervised learning, unsupervised learning, reinforcement learning, and self-supervised learning. First we will look into the supervised learning. So supervised learning mainly deals with the labeled data. Here the model has been trained with the labeled data so that it can predict the target data. Whenever it gets an input, it maps with the target data and comes out with the predicted output. So the algorithms which are used in the supervised learning is classification and regression algorithms. We'll look into the algorithms in detail in the next slides. So next is your unsupervised learning. In the unsupervised learning, here there will not be any labeled data. It mainly deals with the unlabeled data. Like whenever it gets a data set, it has to find the hidden patterns and structures in the data sets and comes out with the predicted output, right? So in this case, it will be dealing with the clustering algorithm, association rule, as well as dimensionality reduction. So next is your reinforcement learning. In the reinforcement learning, the system, the AI agent actually deals with the real-time environment. Here there will not be any training will be given. All the training will be on the real-time environment. It mainly deals with the trial and error method. Whenever an agent performs well, it will be awarded. When the performance is poor, it will be penalty. It will find some penalty. So the best example for this is robots and game playing. For example, when you play a game in the mobile phone with the chess games, the AI agent will be in the opposite side, so it will act according to our movement in the chess game, right? So next is your self-supervised learning. This is the most advanced technique where the AI agent predicts what the person is trying to convey the message. For example, in the Gmail, when you type a message, when you compose a message, it automatically gives the next word, what will come next. So in that, or else when you type a message, so it reads our mind and gives the predicted output. This we call it as a self-supervised learning. So next is your machine learning algorithms. We know algorithm is a step-by-step process where the sequence of action can be carried out. So it gives a predicted sequence of action should be carried out in the machine learning, right? So this we call it as an algorithms. For example, when you wake up in the morning, when you want to brush your teeth, you have to follow some sequence of steps to complete the task. Like you have to take a brush and you have to wet the brush, and you have to apply some paste over it, and you have to make use of it. So brush your teeth. So similarly, the machine, when it uses the algorithms, there will be the sequence of steps. Instruction should be given to the machine to complete the task. So when it gets the input, the sequence of instruction should be followed and it predicts the output. So we'll see the supervised algorithm. First was the supervised algorithms. In the supervised algorithm, as I said earlier, here it comes out with the labeled data. So the main goal here is to learn the mapping function from the input data to the corresponding output data, and it predicts the output, right? So in the linear regression, it mainly deals with the dependent continuous values, where it deals with the dependent and independent variables. It has to make the difference between the line should be the best fit for the linear regression. For example, if you want to predict the price of the house, so it mainly deals with the price of the house, deals with the size of the house, right? So here price is depending on the size of the house. So size acts as the independent variable variable and price is going to be act as a dependent variable. So in the linear regression, the slide should be best fit straight line. The line should be of a best fit straight line. So next is your logistic regressions. In the logistic regression, it deals with the binary classification, where it will have it may be a binary classifications or multi-class classifications. The results will be the probability of yes or no, or it will be like whether the customer is likely to buy this product or whether they are not willing to buy the product. So it will be like a yes or no binary classification method. So next is your decision tree. So in the decision tree, if you have the data set, if you want to come out with a decision tree, you have to take some value for the root node and comes out with a leaf node, right? For example, if you want to make a decision tree for a student's mark list, what you will do, the range will start from 0 to 100. So in between, the value can be taken as a mid value for making the decision tree, and you can predict the output. So here 50 can be taken as the root node and less than 50 on the leaf node, and more than 50 for the another side of the leaf node. So the further classification can also be done in the decision tree. So these are the three main algorithms which are used in the supervised learning algorithm. So next is your unsupervised learning. As I said earlier, in unsupervised learning, it deals with the unlabeled data, so where it is going to find the hidden patterns and structures from the data set. From the given data set, it will find the patterns and structures, right? So first it makes use of the clustering algorithm. So in the clustering algorithms, it classifies the image, it separates the image according to based on the colors or similarities or some kind of differences. For example, in the data, in the raw data, it is given as the images of the fruits. So it classifies, it makes use of the clustering algorithms, and it classifies according to the color different kinds of, it classifies different kinds of fruits. So this makes use of the clustering algorithms. Next is your dimensionality reductions. In the dimensionality reduction, for example, if it has n number of attributes to identify the hidden patterns, in that case it makes use, and it will reduce the dimension by reducing the attributes, the irrelevant attributes, and noisy data has to be removed. So this can be done with the help of the pre-processing the data. In the pre-processing, the cleaning of the actual data to be done, and the irrelevant data, the data which is not relevant for the finding the prediction, has to be removed. This will helps to reduce the dimensionality. This process we call it as a dimensionality reduction. And next is your association rule. In the association rule, it makes use of one of the most important algorithm, which is market basket analysis. So in the market basket analysis, if I own a supermarket, I just want to know what is the pattern the customer is likely to buy. In that case, I will be taking all my data set and I will be analyzing the data. The customer who are buying the bread are likely to buy the butter. If the customer is likely to buy, the customer who are likely to buy the bread or likely to buy the jam. So these are all the associated, the product, one product is associated with the another product. So this mainly deals with the a priori algorithms. It goes out with n number of iterating process, and finally it comes out with the solution. So in the association rule, in main algorithm used here is market basket analysis. It finds the analysis about the customer, how the customer is likely to buy the product. According to that, the storekeeper can make use of it, and they can keep the product. If the bread and butter is kept along, it will be easy for them to buy. So these are all the algorithms which are used in the unsupervised algorithm. Next is your reinforcement algorithm. In the reinforcement algorithms, it mainly deals with the real-time environment. Here the AI agent deals with the real-time environment, where if the agent performs well, it will be awarded. If the performance is not up to the mark, then it has to be learned from the experience, and in the future it may not occur, right? So in this case, it is trained with two methods. One is model-based method, and another one is the model-free method. So in the model-based method, it makes use of the stimulated environment. A simulation has been made where the agent has to be trained. For example, if you want to give the training for the robots, the simulated environment has to be created where the agent mainly deals with, and it is likely to work in the real-time environment. Next is your model-free method. It is like a trial-free method. As I said, it is like a trial-free method. There will not be any simulation. The agent is likely to deal with the real-time environment like a Google Map. Google Map will have the route already. It will have the route from one place to another. If a new person is trying for some other new route, it will take that route as an example, and that route will have the higher priority if it takes less time. So this we call it as a model-free method, since it takes a real-time environment as a trial and error method. Next comes to our important topic, cross-validation in machine learning. So who is validating all our results? We are continuously telling we are getting the input and we are validating the input, and we are making use of the algorithms, and finally comes out with the output. So the cross-validation in the machine learning technique, which is used to evaluate the performance of the system by testing it to the multiple subset of the data. So it is going to validate the performance. We are using number of algorithms. These algorithms are going to be validated in the cross validation. So it will utilize our data in a better way. So how it is going to make use of the cross validation? So here it is going to split the data into two parts. One part is for training and another part is for the testing the data. So the entire data set is to be divided into two main parts. One is for the training the data and another is for testing the data. So it has to perform the n number of iteration. The first step is to split the data, and next is to train and test the data, and finally it has to repeat the process of training and testing for the n number of iteration, and the average of all the performance has to be calculated. How the children will be training in the school, the teacher will be training the children in the classroom. Once the classroom session is completed, after a few months there will be examination for children. So similarly here training and testing has to be done for the data, and in the testing the validation, the actual validation for the result has to be calculated. This we call it as a cross validation. So it is used to perform the evaluate the performance of the model. So we have different types of cross validation: the holdout cross validation, k-fold cross validation, stratified cross validation, leave one out cross validation, and leave p out cross validation. So these are all the different types of cross validation we have. The first one is holdout cross validation. This is the simplest form of cross validation, like a normal cross validation. Here the training data is we have to split the data into two types. One is training and another one is for the testing the data. In the training it takes 80% of the data for the training, and remaining 20% of the data is taken for the testing, or else you can change it for the 70-30, whatever the ratio it may be, but training data will be more than the testing data. So here they have taken 70% of the data for the training and remaining 30% for the testing. The model has to be trained and it has to be tested. But in the holdout cross validation, it performs a task only once. So here the accuracy will not be high as that of other cross validation method. So the estimated output will be very less in the case of holdout cross validation. So to overcome this, we make use of the k-fold cross validation. So in the k-fold cross validation, what will happen? It is also one of the technique used to evaluate the performance of the machine learning. So it makes use of the k-fold. K-fold is nothing but if suppose I have some 1000 data sets in my data. So what will happen? I have to take the value of k. I have to divide the data set equally, k number of times. So I can divide the data like 200 for each testing and training the data set. So here I have taken the k value of 5. So what will happen? 200 data set for each iteration. So first 200 data set will be used for testing, and the remaining data sets will be used for the training the data. So the process here, we have the sequence of steps. Split the data into k folds, divide the data set into k subsets of the folds, test and iterate the process. So we have to make use of k value is 5. When k value is 5, k minus 1 folds for training the model. So 200 data set is used for testing, and remaining 800 data sets should be used for training the data. So after that, after completing all the process, the average of the n number of iteration has to be taken as the final output. So in the next iteration, next 200 data sets should be used for testing, and the remaining 800 data sets should be used for training the model. And in the next iteration, another 200 data set will be used for testing, and remaining data set should be used for training the data set. So in this way, it has to cover all all the subsets of the data. The testing should be carried out over the entire 1000 data sets of the data, so there will not be any bias in the result. If suppose I have class 0 and class 1, if my class 0 will be from 0 to 600 data and class 1 will be of 600 to 1000 data, what will happen if I give the training for only this 700 data set? Then my result will be biased to class 0. So that will not be carried out in this k-fold cross validation. To avoid this biased result, we use k-fold cross validation. So it will be using all the subsets of the data for testing and training the data. So next method is stratified k-fold cross validation. This is the most enhanced k-fold cross validations. It is also used to evaluate the performance of the model, and in this model the accuracy of the result is very high. So the main method here is we have the two here it uses the binary classifications. So we have two data sets, two classes. One is class 0 and class 1, and class 0 participation is 80% and class 1 is 20% among the samples. We'll see with the small example here, 100 samples of the data. For example, imagine a binary classification data set with 100 samples. If suppose I have 100 samples of the data, for the 80 samples are from class 0 and 20 samples are from class 1. Here I have 80 samples from class 0 and 20 samples from class 1, and we are splitting the data into 80% for training and remaining 20% for testing the data. So what will happen now? The stratified sampling of the same data set will be training data set. Here the same proportion of the testing and training has to be maintained throughout the iteration of the process. If suppose I take the testing data for the first 200 data set, in the testing data set the participation of class 0 and class 1 should be of equal proportion. The proportion should be equally distributed among all the testing and training the data. There should not be any change in testing and training the data. So this will increase the accuracy of my result. There will not be any bias in the result. So in this training set, 80 samples are from the class 0. So 80 samples of the class 0 will be of 64 of class 0, 80% of 80, which is 80% for testing. In the 80% of training data set, 64 of class 0 and 16 from class 1 should be participated. So it will have the equal participation over the entire training and testing data set. So next is your test data set. In the text data set, we have 20 samples. In the 20 samples, 16 from class 0 and 4 from class 1, because we have total of 100 samples we have taken for training and testing. So among that, 80 samples are used for training the data set and 20 samples is used for testing the data set. In that, 64 samples for class 0 and 16 samples from class 0, 16 and 4 samples for class 1. This ensures that equal distribution of male and female, equal distribution of training and testing data throughout the entire folds. So stratified cross-validation is provides more accurate result than compared to the k-fold cross-validation. So this ensure both training and test sets provides an accurate representation of the full data set class proportion and better generalization in the evaluation result. And next is your leave one out cross validation. This is one of the important cross validation, but this method is not applicable for large data set since it iterates the n number of times. If suppose I have some 1000 data set, then the iteration will be taken for n number of times, 1000 number of times, because it is going to take only one data set for the testing and remaining 999 data set will be used for training the data. So it takes, in the first iteration, it takes one data set for the testing and remaining n number of data sets will be used for training the data. And in the second iteration, it takes one second data set for the testing and remaining data set will be used for training. So in this way, it is going to go for n number of iteration process. So this process is repeated for each data point in the data set, resulting in training and testing cycles where n is the number of observation. It goes with the n number of observation. So the leave one out cross validation is done. Each individual observation serves once as a validation set, while the remaining n-1 is used for training and used for observation is used for training. So the leave one out cannot be applicable for the large number of data set, but the accuracy of result is very high. It will be applicable only for small data set. So next is your leave payout cross validation. In the leave payout cross validation, it is similar like leave one out cross validation, but instead of one used for testing, here the p number of, we have to take the assign the value for p, so the p value will be used for training and testing. So we have to take the value for p. In this case, I have taken the value of p as 4. So 4 data points are used for p value, and among that 4, it takes 2 data sets for the training and 2 data sets for the testing. So among that 4 data points which I have used for testing the data, the remaining data sets will be used for training the data. The first 4 points will be used for testing and remaining for training. In the next iteration, it changes the data set. Here the first 3 and leaves 1, and it takes the 3rd, 4th data, 5th data for the testing. In the next iteration, it takes 3 and it leaves 2 and it next. So in the 4 data points, it comes out with all the possibilities like training, testing and training and testing. So in this way, it goes out like a 6 possibilities for among the 4 points. So it goes out with the n number of iteration. The iteration will be number of times here in the leave payout cross validations. So this validation is also not applicable for the large data set, since it goes with the n number of iteration. Even in the testing data set, it will comes out with all the possibilities of the training and testing. It takes 2 data for the training and 2 data for the testing in the leave payout cross validation. So this is applicable only for the small data set. This is here the accuracy of result is very high, but quickly become exhaustive for the large data set. This is not applicable for the large data set. So these are all the different types of cross validation method we have: hold-out cross validation, k-fold cross validation, stratified k-fold validation, leave one out, and leave payout cross validation. Let's see some of the sample questions. So sample questions. This is in a data set of 1000 samples, 5-fold cross validation is used. Approximately how many instances are in each test fold? So we have the options like 50, 100, 200 and 500 as an instances. So we have the 1000 samples. What will happen if I go for 5-fold? So I have to divide the value 1000 data set with the 5. What I will get is 200. So here 200 instances are taken for the each test fold. The testing fold will take the value of 200 in each iteration. The first iteration, it will test first 200. In the next iteration, it will test for the next 200 to 400. In the third iteration, it will take the value from 400 to 600. Similarly, it will go on with the until 1000 data set. So next is here, which of the following best justifies using stratified k-fold for classification? So what the stratified k-fold classification best is? The faster training, ensure the same class distribution across folds, avoids feature scaling, reduces model complexity. So in this case, it ensures the equal, stratified ensures each fold approximately and have the class proportions. It has in the stratified cross-fold validation, it maintains the proportion of class 0. If there is binary classes, it maintains the distribution of classes over the entire training and testing data set. So the best suits for this is ensure same class distribution across the folds. So next is here, if you perform a leave one out cross validation on a data set with n samples, how many models do you train? So if you are going to perform the leave one out for n samples, how many iteration it will take? Definitely it will take n number of iteration, because in leave one out it will take only one data set for the testing and the remaining data set for the training. So it will go for the n number of iterations. The first option is 1 and log n and n to the power 2. Here it will goes with the n number of iterations. So the one model per left out for sample. And final question is, in a binary classification problem, the training set has 80% of the class A and 20% of class B, and a learner reports 90% accuracy on the training set. Which of the following statement is most likely to be true? The model is performing very well and well generalized well. The model is likely trivial, always predicts a class A, and the accuracy is misleading. The model has a high recall for class B. The accuracy automatically implies high F1 score. So in this case, we already know the participation of class A, class A is 80% and the participation of class B is 20%. So by default, the result will be biased to class A, right? So we have 80% participation of class A. Even in all the distribution, the equal participation of class A, class B is very high. So it goes with the proportion of the accuracy, means either it is doing something non-trivial, right? So high accuracy is misleading here. The model is likely to be trivial and the accuracy is misleading. This option will be correct. So these are all the few questions we have. Let us continue the session in the next gate session. Thank you all.